The world is a buzz of communication. Every second, countless emails, messages, and videos traverse the globe. But have you ever stopped to wonder how this information travels across vast oceans? The answer lies in a hidden world beneath the waves, a world of cables that connect continents and carry the weight of our digital lives. Over 99% of international data traffic travels not through satellites, as one might imagine, but through a vast network of undersea cables. The Oxford Internet Institute has charted the world's fiber-optic connections, imagined as a metro system. They are the unseen arteries of our planet, silently pulsing with data and connecting us all. The undersea cable system is a marvel of engineering. It is a network of interconnected cables that stretch across ocean floors, connecting continents and islands. These cables are not laid in a straight line, but follow specific routes, carefully chosen to avoid underwater obstacles and geological hazards. Cables are designed to withstand immense pressure, extreme temperatures, and the corrosive nature of salt water. They are composed of multiple layers, each with a specific function. At the heart of the cable lies the fiber-optic core, hair-thin strands of glass that transmit data as pulses of light. Surrounding the core are layers of copper, steel, and polyethylene, providing insulation, strength, and protection from the elements. The magic of undersea cables lies in the fiber-optic core. These thin strands of glass act as conduits for light. Data is encoded into pulses of light, which travel through the glass fibers at incredible speeds. The light signals are guided along the fiber by a process called total internal reflection. This ensures that the light stays within the fiber, minimizing signal loss over long distances. The result is a high-speed, high-capacity communication channel that can carry vast amounts of data across oceans. Deploying undersea cables is a complex and challenging task. Specialized ships equipped with advanced technology are used to lay the cables on the ocean floor. The process begins with careful surveying of the seabed to identify the optimal route. The cable is then carefully lowered from the ship, paying close attention to tension and slack. Underwater robots, remotely operated vehicles, ROVs, assist in maneuvering the cable and ensuring it is properly positioned on the seabed. Once the cable is in place, it becomes a conduit for information. Data, in the form of digital signals, is converted into pulses of light at the cable's origin point. These light pulses then travel through the fiber-optic core at incredible speeds. The use of light as the information carrier offers several advantages. Light signals are not affected by electromagnetic interference, ensuring reliable data transmission. Furthermore, the speed of light allows for near-instantaneous communication, even across vast distances. After traveling thousands of kilometers across the ocean floor, the undersea cable reaches its destination. Here, it connects to a landing station, a facility that acts as the interface between the undersea cable and terrestrial networks. Within the landing station, the optical signals are converted back into electrical signals. These electrical signals are then amplified and transmitted to the terrestrial network, connecting to data centers, internet service providers, and ultimately to our homes and devices. The integration of undersea cables with terrestrial networks is seamless. Data flows effortlessly between the underwater and land-based systems, ensuring uninterrupted communication. The landing station acts as a bridge, facilitating the transfer of data between the two domains. From the landing station, data is routed to its destination, traversing a complex network of routers, servers, and fiber-optic cables that make up the terrestrial internet infrastructure. Despite their robust design, undersea cables are vulnerable to various threats. Natural disasters, such as earthquakes and underwater landslides, can damage or sever cables. Human activities, such as fishing and anchoring, also pose risks to the cable infrastructure. Repairing damaged cables is a complex and expensive undertaking. Specialized ships equipped with ROVs are deployed to locate the fault and retrieve the damaged section of the cable. The cable is then spliced and repaired, restoring the flow of data. Maintaining and protecting the undersea cable network is crucial for global communication. Cable operators constantly monitor the health of the cables, using sophisticated systems to detect faults and potential threats. Efforts are underway to develop even more resilient cables, resistant to both natural and human-induced damage. The ongoing maintenance and protection of this hidden infrastructure ensure that the world stays connected, facilitating the flow of information that shapes our modern lives.